mix each other. I have found a way later on. So we will introduce the problem we're gonna face. We will introduce what is called vector, basic operation between vector. We will explain something called linear independence. We will introduce linear subspace and relate linear subspace to problem of linear algebra. So the usual way to see linear algebra, at least for management science, is to provide tools to solve this kind of problem. Say A1, 1x1 plus A1, 2x2 plus A1n xn equal B1 A1 2 x A21 x1 plus A22 x2 plus A2n xn equal Bn. And so on. An 1x1 plus an 2x2 plus an xn equal bn. Sorry, I had anticipated this, but it should have been b2. But it doesn't really matter. So linear algebra should provide tools to solve system of what are called linear equations. First of all, the way in which usually is presented, at least this as a beginning, it's not clear why linear. And second, it provides little geometrical interpretation or intuition. But instead, what linear algebra makes, it's pretty simple. It's something some of you have already done. So you have, for instance, a plane in R3. We will call it hyperplane, but doesn't really matter the name. You take another plane, and you're trying to see whether they intersect, for instance, or whether they don't intersect, whether they're parallel. What has this to do with linear system? What we are going to see is that, after all, linear, so a plane can be described through a set of solution of a linear equation. Thus, naturally, the intersection of two planes can be described as a solution of a system of linear equations. If the system has a solution, the two planes will intersect. Otherwise, they will not. But if you think to what we have seen just previously, let's try to write, let me try to write a tangent plane. The tangent plane to whatever function as this form, z equal z0, where this is a given value, plus a1 x minus x0 plus a2 x minus x0, where this is delta f delta x, sorry, here it's y minus y0, y minus y0, and x0 y0, and plus delta, here you have delta f delta y, y minus y0. So you can rewrite all these things as z minus a1x minus a2y equal b, where b is equal to what? Z0 minus a1x0 minus a2y0. So this is basically this tangent plane, which is a particular plane, is described as a solution to a linear equation. This is the idea. I mean, we are not interested in tangent plane here. We're interested in plane, intersection of plane, and other linear and affine spaces. And then if you go, usually, in Italy, traditionally, in mathematics, when you study mathematics, you don't have explicitly a course in basic linear algebra. The course in linear algebra is called geometry. And exactly for this reason. So let's go to the formalities. What is this kind of thing that you may probably have seen in high school that are called vector? A vector is a way to call any number in Rn. Sorry, any, let's say, n-pole in Rn, any point in Rn. If you are, and it's something you have already seen here. So you can call a vector an element of Rn. In some sense, calculus of more than one variable, and also calculus of formula of one variable, is making calculus on vectors. To be precise, we will add more structure to our